Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now. Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello, guys, and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, and today we are back with our next problem of the day, which is smaller sum. So, first of all, before starting, please let me know if I'm clearly audible and visible to you all, so that we can start our class. Just a plus one if I'm audible and visible, so that we can start. Hi, Matbar. Hi, Risip. Hi, Kisori. Good evening. So, yeah, guys, today I was quite late, like 1 hour. So, today's from 7 p.m. I hope that's fine, and please comment for today. So let's start today's class, which is the smaller sum. Okay, it's a problem based on like I can say binary search approach. Okay, great. Okay, thanks Susie for confirming. Let's start today's class. Uh, Yeah, amazing. So, guys, you can see the problem. The problem is that you are given an array ARR of n integers. For each index I, you have to find the sum of n integers present in the array with a value less than ARR of I. So basically, you have to find the value or the sum of all that values which are less than that particular number. Okay, and for every index you have to do it. If you have to do it for a single index, then it is a better. But because you have to do this thing for every index present, then it becomes a difficult thing. Let's see how. Let's take example. Somehow better example I will take. Hi, hello, Nakaj, hello. Let's say the example is like this: 5, 3, 8, 1, 6, 2, 7. By the way, here we can have duplicate elements also. It's completely fine. Okay. Now what I will do, guys? I will first like for every element, I have to tell the sum of all the elements which are less than it. I have to tell the sum of all the elements which are less than it. So let's say we are at zero. Okay, we are at zero. So zero index. So we have five here. So how many elements are there which are less than five? Three, one, and two. So its sum will be six. So इसका answer हो गया six. Similarly, for three, how many elements are there? One and two. Sum is three. For eight, you can see all the other elements are smaller. So if you see the overall sum will be 18. For 1, there is no smaller element, so it will be 0. For 6, there are 1, 2, 3, and 5 smaller element, means it will be, I think it will be somehow 6, 11. For 7, for 2 guys, there is only 1 present. And for 7 guys, apart from it, all the other are present. Like it will be, I think, 20. And guys, it will be, I think, 20. Wait, am I wrong? Am I wrong somewhere? Like it's 8, 8, 16. Okay, it will be 26 exactly. I think I have done some wrong. Okay, I think I have done some wrong. Like for 8, we have to find the sum of all the elements. Na? So it will be 6, 3, 9, 15, and 15, 8, 23 will be there. Got it. And for 7, what we have to do is, let me just 7, so it will be 16, I think. 70. Please help me with that. Am I right, guys? Like with for 5, the lesser elements are 3, 1, and 2, so it's 6. Okay. For 3, the lesser elements are 1 and 2, so 3. For 8, all the elements are smaller, so it will be 7 to 14, 16, 19, 24. Okay, it is 24. Got it. 24. Then for 1, there is no element. For 6, we have 5, 3, 8, 2, 11. Okay. For 2, we have 1, and for yeah, I think now it's completely fine. Okay, I think now it's completely fine. So this is your answer. Means you have to find the sum of all the elements which are less than that particular element, which are less than that particular element. Am I right, guys? Just try to press 1 if it is clear. So guys, how we will find this thing? So guys, first of all, what I will do, like let's say this is the array ARR. Okay, I will take another array. So I think that the array is given to you. Array ARR is given to you. So first of all, I will take a different vector here, which is sorted. So I will take a sorted vector here. Let's say like this. So now what happens? If the vector is sorted, means now it is very easy. What I will do? Let's say I have 5. So what I will do, I will find the lower bound of that number in this vector, and all the elements before it will be my answer. So I will find the prefix array also. So 1, 3, 6, 11, 17, 24, and 32. Okay. Now guys, what I will do? See. Okay. Everyone knows about lower bound? Let me tell you what is lower bound. Lower bound gives you the index of a number, or I can say the first index of such a number, which is less than equal to a number. Oh, sorry, which is greater than equal to a number. So let's say I will ask you, what is the upper bound, lower bound of 6 in this array? So in this array, the lower bound of 6 will be this index. If I will ask you what is the lower bound of 4 in this array, so because you can see guys, 4 is not present. So if equal is not present, you will check for the greater. So it will give this particular index. Got it? So using lower bound, I can find the index from where greater than or equal to elements are coming. And all the elements before that are smaller. So I can simply find the sum till there using this prefix array. Got it? That's our approach. So what I will do, as it is given here, first of all, we'll have another vector of long. So basically, I will have two vectors. One vector will be vector v. Vector v will be nothing but it will be equal to ARR only, which will be sorted. So vector v I will sort so that I can apply lower bound there. Okay, so this is vector v. Got it? This is vector v. Now I will have one more vector called vector pre, that the prefix sum vector, the prefix array vector that will have. Okay, exactly. Lower bound of 4 is 5. Exactly the same. Okay, and I will have the last vector as the answer vector, where I will store the answer. So after having this vector v, what I will have, I will also find the prefix sum. So the 0 is equal to v of 0, and for else I will find the value of our prefix sum. So I will say pre of I is equal to pre of I minus 1 plus ARR of I. Okay, plus ARR of I. That is what we will have. Got it? Great. Okay, amazing. Now guys, the next point. The next point is now for every number I will find it's fine. Like let's not make it more complex. It's simple. Like the space complex, then also it will not be affected. Okay, if we take a vector or two vectors, it will be still fine. Okay, so no worries. I have to explain to beginners also who are watching the live, so I will not make it more complex for someone who don't know about pairs much. Okay, great. So that's the thing. Now what I will do, I will iterate through my original array. And for my original array element, which is ARR of I will find the lower bound of it. Let's say LB, lower bound. So I'll find the lower bound of that particular number in this vector, sorted vector. So V, how we find the lower bound? So we take V dot begin, comma V dot end, and then the number ARR of 5 for which we have to find lower bound. Okay. Now let's say, oh sorry, yeah, I got it. Yeah, sorry. Thanks for it. That was a mistake. Okay, great. Now guys, what we will do is, what if that particular number that we are searching for is the first number of the array. So you can see, let's say we are searching for 1, lower bound of 1. So when I will find the lower bound of 1, so it will come at the very first iterator. Means if my iterator is equal to V dot begin, means the number that we are searching for is the first number of the array. That means there is no smaller element, and if there are no smaller element, my answer will be simply 0. And for all the other cases, what I will do, I will first find the index. See guys, this gives you a iterator. This value gives you a iterator. So you have to convert that iterator into an index. And for that, what we do, if you have to convert it into an index, for that we will take it like this. Let's say index is equal to, we subtract it with the first iterator, that is V dot begin. Now this will give me the index of that particular point. Let's say I'm saying what is the lower bound of 4. So it will not give me index number 3. It gives me the iterator pointing towards it. But if I will subtract it from V dot begin, it will then give me index number 3. Okay, great. Now guys, if my number or my lower bound is at index number I, let's say, and I want a smaller element, so I want sum up to the previous element, na? So my answer will be a prefix sum up to a previous element, 1 less than it. That's all. And at the last, I can simply return my answer. If we will run this code, let's see what's the happening. Okay. So I think it's of int. So I think this vector should be of int, but pre should be of long data type. I think so. What's the problem we are having? I'm not getting what's the problem we are having here. Okay, sorry. Yeah, got it. It was not a comma, it was a dot. Okay, got it. Yeah, now we got the right answer. Great. Thanks for it. Joseph. So you can see all the tests has been passed. So if you will do this value by brute force approach, it might have take what order of n square time complexity, because for every number I have to again iterate. But because we are doing it using binary search, so you can see this lower bound function will take order of log n. This will take order of log n, and it is called n times. So I can say that the time complexity for this particular problem is order of n log n. And if we talk about the space complexity, it's also order of n, because we are having multiple different arrays like array vector v, vector pre, for the prefix 7 different vectors. Okay, and n log n because binary search also, and we are also sorting the array. So for both the cases, it will be n log n. Okay, so this is how we are solving this particular problem. Okay, is it fine, guys? Is it clear to you all? You have done through map. Yeah, for map, it's also fine. Okay, great. Okay, you haven't sorted. Yeah, then also it will be like fine. Okay, then thank you guys. Thank you for watching this live. I hope that you have got this particular video this particular problem. Let's meet again. I think next Friday. Now my turn is in next Friday. Till then, happy coding. Bye bye. Take care. GFG कर लो हो जाएगा.